Hello. Today I think I'm going to try and make it a short video. First I'm going to clean up all of the instances where I have die logic, which prints a message and ends the process, and just make a utility macro to do that more easily. And the other thing I would like to do is also figure out what that crash is that we saw before. So if we do ty, which causes which is the prefix for codes like this, which has two characters in it, we get a segmentation fault. So I want to debug that, and I don't think I want to fix it today, but I do want to actually at least figure it out so that I can think about how to fix it. So let's look at so first we're going to do the cleanup where we have this like this die function. We're going to create a die function. So as an example of what we're going to clean up, if we look for exit, let's see, let's pick a random result from here, 114. Okay, here. So this is a die. This is we're dying here. So the thing is, this is from a user error. So I don't really know if how we want to handle that. I'm thinking that for dying, we kind of want to do this for errors that we don't know. We don't really we didn't really expect, like maybe some kind of a failure with a system call. But at the same time, I can't think of a real reason to not use it here. I mean, it's probably just fine to use it here as well. Even though I do want to print out some debugging information that the user probably doesn't usually want to see. So yeah, I think we can just use it here. The only drawback I can think of is that we will have to pass 0 for the error number, because we don't have an error number associated with this. And the other problem is we 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 might get like file name and line number printed out here, where we probably don't really want it that much, but that's okay. Sometimes when I'm not really sure what I want to do, I just pick the solution that has the least, that results in the least number of lines of code. And so here we go. Let's do so it's going to be something like void die, and we'll take a int error number, so we don't conflict with the global, and then we have a char const format, and then that. So, oh, but we also want the file name and line number, so maybe we do need a macro here. Okay. Define die error number, and then dot dot dot. Okay. And so how are we going to do this? So this is going to be pretty simple. xf printf standard error, fatal error at file and line number, and we are going to do file and line, then xf printf. We're going to add the var args at the end. And how do we do that? We did this with bug. How do we refer to the var args here? Right, like this. Okay. So we're going to do something very similar here. Let's yank that. And standard error, and then we print a new line. And then if we have an error number, then we're going to use that error number. Then fprintf let's indent this. But the thing is, if we indent it, we don't know if the caller may want multiple lines. So let's not indent it. Let's just do it like this. F printf, xf printf, and we're going to do standard error and %s stir error number. So actually, we don't really need xf printf. We can do xf put s, and then error. Oh, but we do want a tab, right? So we kind of do want this. Xf put c standard error. We could also do a format, but it could go either way. Exit random number. Time to get a random number. Okay. 228. Okay. Fatal error at such and such. VA args and exit. Okay. Now what I want to do is I want to make sure this kind of works the way we expect. So I will do something like about I'll just die here. 0 and oops. Okay. Die. Implicit declaration of die. Okay. Usage. Defined but not used. Okay, good. New sorts. Fatal error at main.c, line 33. Okay, good. So we can actually give it a 0 for error number, and we don't get a compiler error for like unreachable code. That's very good. I was worried about that. So okay, let's undo the changes in main, and now we have this. So we're gonna have to look for all uses of exit, and okay, exit. Oh, there aren't that many actually. Okay, so let's just go through all of them. But when I did the grep before, there was a lot. I guess that's because we had usage that we're not calling the function. All right, let's go ahead and fix all this. ConstDB order.c 68. Okay. So yeah. Die 0. Right. Delete. Delete there. Right. Okay. Let's make sure that still builds. Good. So this is an error that says that the code point is is not a target, or it's not supported. Code point is less than 800. Decode code point. I guess that's because 800 there's no kanji or Japanese characters before 800 in Unicode code points. Okay. Anyway. So that probably makes perfect sense to use the fatal error thing. Exit, git grep, exit. Alright, edit free kanji keys, 13. Okay. So this is like a user error. Right, die, 0. We don't want the new line. by the way. So we have to change that. So let's go back to check kanji database order. We don't need the new line anymore. Code point is long. Okay. Let's make printf error. Edit. What were we just changing? We were just changing free kanji keys. Free kanji keys. So here, the thing is, we have a way to return the error. So I don't really know if I like the way that we're dying here. So maybe we can do this xf put s. Actually, let's just free kanji keys. Kanji keys dot c. Return 200. Okay. Yeah, this is interesting. I'm not sure why I did it this way. The thing is, if we want to test the error, then we should be using something like this. And so if we want to test the error, we also can't use die. So maybe the right criteria of whether or not we use die is whether or not we're okay with not testing that particular piece of code. So in this case, we may want to actually test it, like the error that we don't allow passing arguments. But even though we happen to not be testing it, but we may want to. So in that case, we don't use die. We use return, and we print to the testable stream, which can be swapped out for a file during tests. And also, we can't use exit if we want to possibly test the code. Anyway, we can also test die. I guess we can like change this to have different behavior during tests. That's also a possibility. Okay. Anyway, still builds git grep exit grep. Okay. Put .c 18. Okay, here. Alright, die. Enable set terminal attributes. So we have error no and let's set attributes. So I'm gonna want to have to. So let's not do it here yet because this is code that I added that I want to translate. Let's not do it as that one yet. So first, what we probably want to do is go to master, git checkout h8. All right, let's. I'm gonna change only the stuff we did not add recently in these like pending these things, because I'm gonna translate this and rewrite it before I upload it. So let's keep on going. We're gonna skip this one. Exit. Input.c kanji distribution.c 110. So here we have a die. Right. And here we got the same deal. That's better. Next we do keyboard.c 44. Go. Oh, I didn't actually pass 0 here. Okay, so I think now if I don't pass 0, do I get a compiler error? Yes, I do. Okay, good. I was thinking maybe I need to change the macro signature so I do get an error, if I don't put a 0 there, because that 0 is going to be hard to it's going to be easy to forget to do. Util dot h. No, we can just do another grep. Exit, edit, keyboard dot c. Okay. Did I already fix this one? Keyboard dot c 44. Here we go. F right error. Okay. So we do a die, error no, and there. Okay. Grep exit, rank coverage dot c. All right, 56. Die. No error. Oh, we still want the brackets here. If we use brackets up here, the arbitrary style I chose was to put the brackets on the other legs of the if else as well. Grep exit. All right, edit test dot c. Okay, 72. Exit. Okay, I guess for here we do want to keep the current exit thing. Verify contents. Yeah, there's no real reason to do it here because the error message changes when the error message is different based on different conditions. So, and I think we may want to print both of these. So, yeah. So yeah, because we don't, either one of these can be on or off. We know both of them are not going to be off. At least one of them will be on, but that's all we know. So we can't really create another die here. We could just say test failure, but I don't really know if I like that much. I'd rather just have the exit. Input.c. Edit. Oh, did I go and change input even though I said I wouldn't? No, it's still there. Okay. Now we do test util 127. Okay, stem failed. Okay. Now this is going to be part of store in temp file. Put temp file creation logic in shared function. Okay, this will also, we're also going to change this with a different kind of timing here. So let's see. So let's not fix that yet. Git grep exit. All right, 134. All right, because these we moved recently, so I'm not gonna change that. And util.c 16. Okay. So let's say die 0 out of memory. Okay. Or calloc out of memory. I'll just keep it as it is. Even though I wonder if that's the correct diagnosis. Can we know that for sure? Is that really why it returned nil? I'm not sure. Out of memory again. Pointer counts. Okay. Report F open failure. Right. That's fine. Report F open failure. And exit. Okay, we can't really change it there. So we can change it here. We'll do a die 0. F gets the error. Okay. Res. Okay, got the same deal here. Die 0, comma f put s. Okay. XF close. If it fails, we print a warning and not an error. Oops. Okay. So here, die 0. Oh no, we do have an error number here. Error, no. Error. Okay. Here, die. Delete, okay. Okay, and we're going to do it again. I think we're almost done. Let's see, error. All right, an fread error. Die. Fread error. Okay. Now, git grep exit. Test util. Before I change all those all these instances in util.c, I should make sure that they weren't changed recently. So if I do git blame util.c, I can check the dates around the things we just changed. So this is June, and this is July. So currently it's September, or rather it's early October right now. So here, okay, here we don't want to change this yet. fgetc error. Fgetc error. This is okay. So we don't want to change this one, I think. 9b7e, 9b7. Okay, here we do want to change it, that's fine. F1, F8. Let me check these. F1, no F1 here, but 97BE we do. That is correct. So, all right, git to blame util.c. Committed yet, out of memory. Okay, here, this one is in the xfgetc function. Next, nothing. Okay, nothing is recent. So the xfgetc. So we'll do a git add patch util.c, and we're going to use this as a fix-up. Let's make sure it builds. Okay, so git add patch util.c, and we're going to stage everything except for that one xfgetc thing. No, xfgetc. No, don't see it here. Oh, did I skip it? I think I skipped it already. Yeah, right here. I skipped it. Okay, so quit. Let's try again. xfgetc. No. F gets here. Okay, so we split for S. So F get C. Yes. F get S. No. Now we can quit. Okay, so GCM M dash dash fix up equals oh, so this is 4, right? XF get C. Yes. Okay. Number 4. So I'll do fix up 4. Okay. Now the other one that we kind of wanted to change was input.c, but I think this one moved around. No, this is input.c. Okay. So this is in the recent commit here. I think we can also commit this now and then declare it as a fix up die. Error no. Set terminal attributes. String.h. Don't really need string.h, I don't think. Okay. So now we can do GCM fix up equals h2. Let's do a blame real quick and make sure I understand what I'm doing. So this is in let's see, die 2f9 DAC. 2f9 DAC. Okay. Now also I want to make sure what I just deleted is also in the same command 2f9. Same commit rather. Yes, it is. Okay. I think we need all the other headers. So I'll do input.c, and this will be the fix up is h2. Okay, so GCM dash dash fix up equals h2 input.c. Okay. Now the rest of the stuff we're going to move it to right here, or right after that commit rather. So we'll do a let's make it one more time. All right, now GCM or add all git commit m is use die macro or make die macro. Okay, let me make sure that we do it consistently because I don't want to. I want to make sure that I pass the right argument each time. So return 200. This is fine. And die 0, 0. Free kanji keys. I'm just thinking, is free kanji keys really supposed to return the error code? Yes, it's a command. So all right, that's fine. Now die, we don't have error numbers. I also want to make sure I remove the trailing new line thing there. And here, trailing new line. Error no. Okay, good. Die. Okay, that looks fine. This looks fine. This looks fine. Memory. All right. Error no, error no. Yep, that's fine. That's fine. And that's fine. Error no. Yes. And that, and that. Now ASPrintf, does that really not return an error? I mean an error no? Man ASPrintf. Error no. Return value. If memory calculation was possible or some of the error occurs, this function will return -1. The constants stir PR are undefined. Okay. It doesn't say if it sets error no. So I'll just assume it doesn't. Error no. Die. Oh, no. Okay. So, oh, but here we didn't put a new line after xf put s. We do want a new line there. So let's go to util.h, die, xf put c. Okay. And I'll amend this. Now I'll rebase and move this to the start. Make die macro. Okay. Screwed something up. Keyboard.c. Edit keyboard.c. Okay. So this thing should have been in, it should have, keyboard right is not, was added here. Move keyboard right to shared function, yeah. So, made a mistake applying this. So what we want to do is we don't want to actually do anything here. Let's delete that. Because keyboard right does not exist as of this commit. So add keyboard.c and git rebase continue. Okay. Keyboard right. Okay. So now we can do this die no end. Error. Okay, now we can do it. GCM fixup is H6. Get rebase I. Okay, now we want to make sure everything still builds at every commit. So I'm going to go ahead and check out 8. Make this. Alright, now check out 7. Oops. 7. Make. Alright, now 6. Make. And 5. Make. By the way, this is my exit code. So I'm making sure that all I'm doing is I'm making sure this is 0 every time. So then 4, make, 3, and make, okay, 2 and make, and then pending, make. Okay, good. So now that we have that out of the way, we made this much. We made the dying logic a lot cleaner whenever we did have to die. So now I won't have to go and generate so many random numbers every time I have a new fatal error condition. And I could have error no be set here. I could pick some error number for the fact that code point stir is an invalid argument. But I guess I won't. I'll just leave it. That doesn't seem super helpful anyway. Okay, so now let's make a debug version. Make C flags equals G. We'll do new sort input end ty. Alright, it fails. So let's do gdb new sort and set args to input and run. Okay. Trace. Keyboard update. Keyboard.c line 82. I already have it open. Okay, so right here we've got the length, which is going to be 6. So that has 2 hiragana characters in it, and it's going to be 6. So here, and then we do char bytes minus, and char bytes is going to not fit. Okay. So yeah, so this is going to be a giant number. It's because it's going to be negative, basically. So it's going to overflow back to a negative number. And I think memset takes an unsigned number here. So it's going to be a giant number that that is obviously wrong. So, okay, how do I want to tackle this? So I actually have been thinking about this. I did know that this would not be enough, that this does not have enough room to store every single possible conversion, converted kanji or hiragana character. I also want to do color coding eventually. And so there's that. Now, I could just change this to have an extra null character in it. So I would just do something like this. Now that doesn't fit, sadly. It doesn't line up anymore. And that is a bit annoying. So it's going to be a little bit harder to kind of maintain this code. But at the same time, I don't know if there's a really better option anyway. So we can, now when we do like cha like that, it is going to it's not really going to fit, right? So we're going to have to put it here. We're going to have to take up I guess two spaces. But the thing is, this is actually only this is only going to fit 1.5. This is only enough room to fit 1.5 of the possible conversion characters, even if it does fit it. I mean, even if we do go ahead and overwrite this line right here, it's still not going to be enough room. It's going to like this line that it overwrites is going to take up a little bit more space when we reprint it. So we could say, hey, if it's 2 characters long, if it's like that, like what I had before, that, then just don't even bother showing the the conversion, the possible conversion of it, and because these ones can just be memorized by the user anyway. But then again, that's not totally true. There are some that are not super self-explanatory, like KYI. This is not a standard kind of thing that you want to type. So it would be helpful to have this as a possibility. So I mean, to show this rather, since that's not a standard kind of thing that you'd want to type. So maybe we need to add one more space like this. We need to make one more space so that it's a little bit longer than what it was before, and then it might overwrite the pipe after it. Or we can just say we convert there's another set of characters called half with katakana, and we can just convert the second portion of it to half with katakana, and that might work. It would fit. The thing is, if I just give it one more space, that is going to fit, but then yeah, I don't know if I like that very much. See, it's going to get complicated when characters take up more than 3 bytes, because there are some characters that will take up more than 3 bytes. So, yeah, how do I want to handle this? So, romaji dot c dot c. We could have it overflow above so that the first character is here and the next character is here. So we essentially kind of do like, over and under, and so it will be written from top to bottom. And the only problem with that, though, is that if this is a shifted code, if there's a shifted code up here, then it won't be visible. But that may be fine as well. The other thing we can do is just not even show anything, just for now, and then fix this later, because we don't really want to have a crashing bug. It's better to just get rid of the crashing bug anyway. So we also need to have a way to figure out whether or not this is 2 characters long, because just because it's more than 3 bytes doesn't necessarily mean that it's more than 2 characters long. So we could have some logic which like splits up the character into 2, and then we print it. We actually print it as 2 here. So we can have a function, in other words, that like takes the converted string and splits it up into individual characters so that we can actually align it onto the keyboard. So the problem is that new sort task. This is getting to be a really nasty file. Part 20. So the problem, what we did, add die macro. More notes. So this is just a grab bag of notes. So the problem is that for a character like let's see here, F. Oops. This character is going to take up more than 3 bytes. And to prove it to you, and echo -n or hexstone. It takes up 4. And so the problem is that how are we going to be able to tell the difference between this and between something like this? This is going to be 6 bytes. This first one, this is going to be 4 bytes. I guess we could say that if it's 6 bytes, we know that it's going to be 2 characters, but other than that, it's only going to be 1 character. That's probably a decent heuristic. In fact, it's probably not all that bad. So maybe, yeah, if it ends up being 6 bytes, that means it's not going to be a single kanji. It can't be a single kanji if it's 6 bytes, because UTF-8, if we look up UTF-8, this is the, oh, that is the first time it actually automatically went to Japanese for me. So where's the table that I'm familiar with? Unicode, Roman, bytes. This is the number of bytes, I guess. Okay, so yeah, it goes up to 4 bytes apparently, if I understand right. Unicode, yes. Oh. Yeah. It goes up to 4 bytes. This is the byte array. This is what it says, byte array. And that means that if something is 6 bytes long, we do know that it's going to be two kind of characters, and that means we can split it up. We can just say first line will have the first character and the second line will have the second character of the 6-character thing, of the 6-character code. So this may actually be not that hard to implement. We will go ahead and do, let's see here. So when we're doing mapable char count, if we do a if we're on a shift, so mapable char count goes up to 80, and we do the shift ones first. So if we have, let's say that if we go here and conversion length is 6, then that means that we add, we're gonna have to change where we are, like go either go up if we're in the lower. So yes, there's no guarantee that the character will be non-shifted. The key in the code may actually be shifted. Like if it's katakana, it will be shifted. So we're gonna have to switch. So if it's 6 long and we're filling in this keyboard item right here, then we're gonna have to turn on shift and then write the character here. But if we're already here and we're writing the conversion string, then we got to unshift and write the next character here. So right now, we have this code which is generic and writes to the keyboard. So let's see here. We could factor this out into a function probably. I think that's what we have to do. Static void right cell, and we do it would be size t. Do we have a type for a key index type? Okay, good. So we can do a key index type, key index, key, ki, and we have a char const str. Okay. So right cell, and this will, so I wonder if this is going to work cleanly. So char offset, so then copy. Okay. So there's a case of we're not writing anything, right? So there's that, and there's the, so I don't know if right cell needs to know that. So maybe if stir is empty, that means that we are we need to actually empty the bytes, empty the string. Okay. If it is, or if it's null, like, okay. I think that makes sense. So if we take char offset, now what does bsearch rely on any of the variables before it? Because that's basically what this part has to do. So full code equals such and such, missing char index, full code. Okay. Missing char index equals ki. Okay. So ki, yes. So we can just move this bsearch thing up. We don't have to do it all the way down there. This takes m, mapping, and mapping dash codes, which is passes an argument, and it takes m and full code. Now full code is set here, so we just move this up. So I'm essentially trying to get all this logic and then all the remaining logic, and take the remaining logic and put it in here in right cell. So m is used here, char bytes is used down here. Right, keyboard p. Okay. P, key mapping, and char offset is used down there. Okay. Ki, it needs ki, and it needs char bytes, keyboard p. Where's keyboard p? Okay. Keyboard p can be calculated in that function. And here we go. Right cell. Okay. And we don't use m now, so if not str, then we do that. Otherwise, we take str. There. Okay, conversion length. Okay, good. So, yes, now we do if not m. Okay, yeah, this is kind of awkward. So if not m, then we right cell key index 0, else right cell key index m dash conv. We can do a ternary operator here, m then m dash conv, otherwise 0. Okay, make. Okay, now actually maybe we don't really need to do the ternary operator. So if it's not m, then we do that. Otherwise, we need to see if it's length of 6. So if Sterling of m dash conv is 6, then well, let's save Sterling here to size t lang equals m dash conv. Or do we need to? I guess we don't actually need to. We're only going to need the string lang once from what I can tell. Then we do something special. Otherwise, we do something very simple. Right cell ki m dash conv. All right. Now here we're going to have to do 2 right cells. So the idea is if ki is high, if it's shift, then which basically means that it's higher, then we're gonna go down. If it's unshifted, we're gonna move it up, because shifted is a later index here in line offset, and shifted is a later value for the key index, or a higher value. So if so yes, now we need to kind of swap it. So we do like int or key index t non-shifted equals ki modulo kanji key count. Okay. Now if so this is either, so now if non-shifted is not equal to ki, or rather if okay, so we want to have the non-shifted and the shifted, and key index t shifted equals non-shifted plus kanji key count. Okay, good. So now we do a right cell, but now we need to get we need to pass a length to right cell, so that we know that Sterling or bytes, stir bytes. How's that? Or stir, yeah, stir bytes is fine. Okay, convlang, because we're going to pass it 3. So we'll do a right cell. Right cell. Oh, here. We don't need to do this. 0. Okay. If not, stir bytes. Otherwise, convlang there, word str bytes. Okay. Good. Now we over here we do right cell k. Let's see. So shifted is the first character. So shifted m dash conv 3, and right cell non-shifted the second. Then we do the second half, non-conv plus 3 and 3. So this is must be 2-kana characters. Okay. And here, okay, let's see. So now we want to save. Now we actually do want to save the string length. Now that I've gone ahead and done all this work, or deleted what I had before. Size t stir bytes equals Sterling. So if stir bytes is 6, unshifted. Okay, darn, now we have to wrap. Let's do this. Stir bytes. This. Stir bytes equals that. Okay. Now we don't want to do it now. So, all right. If stir bytes is that, now we can do this. Now we can actually do this. If stir bytes is 6, how about if stir bytes is less than 6, then it's going to be normal. It's going to be this stir bytes, right? And we can continue. There. All right. Otherwise, it must be two-kana characters. And if stir bytes is greater than 6, we have a bug, because I don't think anything should be more than 6. Bug conv is too long. Okay. Okay. Now let's try this. Key index t. What line is that? That is on line 102. Okay, key index t, shifted, oh, okay. Okay, so maybe we do want to actually make this like this, so conv is too long. Alright, so we'll do it like this. This actually has more symmetry, so it's a little bit nicer to read. Okay. Good. Conv is too long. Make. So now we can, oh, the test pass. Good. So let's try and run input. See what happens. Almost worked. So the second character is correct, but the first character is not being shown. So shifted is non-shifted plus kanji key count, which is correct. And it is showing shifted correctly here, so we don't have a problem with right cell itself, I believe. But must be two-kana characters, and it does seem like we are like hitting this condition here, because otherwise we wouldn't be skipping anything. So shifted. Oh, okay. So the reason why is because we are writing, going back here again and writing to and clearing the cell out. So that must be what's wrong. Okay. So we could just loop through this and set ki first, or we can rather clear out the cells first in a separate loop and then write them later. That would work. I mean, now if this happened to be a shifted character, that means we hit it last, which means we don't have to do it again. So, or we can like set a flag here which says don't actually try and clear out the cell first. Well, let's just do it the simple way. 0 ki is less than. Now we want to do this for shifted characters only. Mappable char count ki plus plus. Okay. Here, right cell. Empty them all out. If not M, then we continue. And now, now that I think about it, do we really want to have only one function for all of this? Maybe we want to have two functions, because really all we need down here that we're pre-calculating is some junk. So what is it? It is memcopy. So I want to factor this. I'm thinking factoring this out into a separate function, this top stuff here, and then having these two be two separate functions. So we're going to change this from one function to three functions. And that way we don't have this branching logic here, which is just a mirror of this kind of dichotomy here of two for loops. So keyboard P is basically the position in the keyboard. So essentially what we need here is the number of bytes and the keyboard pointer. So yeah, let's see. I mean, we could make a struct, which is like the keyboard keyboard slice maybe, and then this has a size. This has a uint 16, uint 8 type. I guess it all fits in uint 16. Uint 16, or rather unsigned. This will be the keyboard, the offset, and then unsigned size is like that. Keyboard slice. And so we have one function that returns a keyboard slice, and another function that that returns that, let's see, will another function that takes the keyboard slice and writes in something here. So I don't know if that's how I want to do it. Maybe, maybe not. Keyboard slice. Yeah. I don't know. That seems more confusing, to be honest. I don't think I like that. Maybe we do just want to have these two different ways of looking at it, two different functions. So we could do like static void get or keyboard slice. So we could have a helper function which implements two versions of write cell. There's the other way of looking at it: key index t, ki, and this would be size t, or wait, how about char keyboard p and size t bytes. Right? Keyboard slice. And there we do char bytes here. Char bytes. Okay. Keyboard slice. Yeah, I guess we can do it this way. Oh, yeah, I think I do want to struct keyboard slice or keyboard cell, maybe. Yeah, slice is fine. Then we do the unsigned offset and unsigned size, or maybe length. Offset length. Okay. Yes. So we do a static struct keyboard slice, ki to slice. And then keyboard slice s. Okay. And okay. Now we do now we're going to return what we want from here. So length and offset. So offset. Okay. So s dot offset equals line offset ki divided by 10. Right? And then we do this check down here. Same thing up here. if k has less than country count, so we do s dot leng is such and such, and s dot leng is that, and s dot offset is that. Okay, s dot offset. Now we can return s. All right. So now we change this to a let's see here, right cell. Okay, to slice. So we'll do a static void clear cell, or maybe we'll use the word slice, clear slice, and struct keyboard slice s. This just does an memcopy here, but we don't really need to do a clear slice exactly. I mean, this is not really doing a whole lot. Keyboard, see keyboard plus s dot offset, and then keyboard plus s dot offset, and then s dot leng. Okay, and then we do a right slice and struct keyboard slice s. Okay. All right. Char bytes, we don't need that anymore. Keyboard p, we don't need that really. Keyboard p equals keyboard plus s dot offset. All right. And char offset, we don't need, I believe. Right. Okay. Okay. Char bytes, right slice. So now I have clear slice and right slice. Yeah, let's just inline this one. Struct keyboard slice s equals ki2 slice, and we do ki s. Okay, then we can do keyboard plus s. Okay, clear slices. Clear slices. All right. Good. Now we do the right slice instead. Right cell, right slice, right slice. Okay. Right cell. Up here we need right slice as well. Right slice. Okay. Good. Getting closer. Stir bytes, stir bytes. How about we change this to yeah, I'm wondering how hard I have to make do to make this like how about I want it all to fit on the line. That's what I'm saying. So s and then bytes s. Oh, we already have an s. So we can call this stir and then lang. Okay, stir len. Stir len. Car bytes. S dot ling. S dot ling. Okay. Minus ling. And then we have stir len. P plus ling. Okay. Okay, 109. Right slice. Okay. So we have to do a ki to slice ki. 116. Okay. Ki to slice. Slice. All right. Clear slice. Don't need that anymore. Okay, make. Good. Now, if we do input in this, okay, it actually works. Good. And okay. Now, if we have a shifted version, this also works. Very good. So now I just need to write tests for what I just did manually, I guess. So, oh, and the katakana works, I guess. T-A-T-A-T-Y. Okay. And then so TYA is a very like common katakana thing, but let's try some unusual input codes which I copied from somewhere. BY, yeah, BYI, this is unusual. BYE, that's a bit unusual. I can do like FI maybe, FI, or F, no, we don't support F. How did I do like this phi sound? FI, oh, but that's disabled. Let's see, let's look for this. HWI. HW. HW. Here we go. Caps lock will work. HW and then, okay, O for full, HWI for phi, HW8 for few. Okay, very good. So I need to write actual tests for this because this is kind of complicated. Oops. Try again. Caps lock is like a pact with the devil. You think that it's going to be useful, but it ends up like screwing you up a whole lot. At least that's how it is for me, because I get into bad habits. I don't turn it off when I should. I don't press it hard enough for the keyboard to always recognize that I pressed it. Okay, anyway, let me just look at this code one more time and make sure it's as simple as I would like it to be. 'Cause this keyboard slice thing is weird. I don't know how much I like it. I mean, right slice is always calling ki to slice. So we could just make this be a key index t ki, and then struct keyboard slice s equals ki to slice ki. All right, and then we've got then we basically have the same deal here. All right, now we don't need to we don't need to call it manually. Delete to s. Right. Right slice. Right. Now slice. Do we want any functions called slice? Care to slice. We actually don't want. So we can just call right cell like we wanted to originally. Then right slice, because we're no longer passing a slice value. Right slice. Right cell. Oops. Right cell. Okay. Good. New sort input. Okay. Okay. So now we want to do input test. And we do long conv strs, right? And we do ty a and hy I. We're trying all the things that I just did before hwi, rather. Is that what it was? HW, yeah, HWI. Okay. What else? Oops. TYA, HWI. accidentally did an undo. So let's go to romaji.c. What else do we have here? DWO. DWO requires katakana. It's not available in hiragana mode or non-caps locked mode. What else? What else? WHO. WHO. GY. Okay. Maybe Y. Oh, that's interesting. So just Y, or capital Y rather, will give you this. That's an interesting looking conversion. Maybe I can make this easier to read. Ergonomic sort. Ergonomic sort. Okay. All right, good. Now we can probably make this and see the results. Cat. All right. So did this actually work? We have TYA. Okay, that looks correct. Then we have HWI. Okay, that's correct here. And then we have DWO, and that looks correct. Then we have WHO, and that's correct. WHO. Yeah. There's no actual H sound in WHO. It's more like a way to say I want this weird set of characters that start weird set of conversions that starts with oo. So WHU, for example, just does a big oo and then a little oo after it. That's kind of weird. Okay. Let's get that copy thing again. Copy. Okay. Make. Good. Okay, so that is great. So we basically did what we had to do. We fixed segfault and allowed showing two-kana chars. Two-kana conversions on keyboard. Okay. And that reminds me of something. Actually, there should be no reason to have a 5-byte thing here. If stir bytes equals 5, that's probably wrong because there's no way UTF-8 character can take up 5 bytes. So 6 means it's two-kana characters. 5 is likely a bug. 4 we don't have any yet, but we will have later. And most of the conversions are 3. So we could say for like 4 or 5 that it's a bug. But for now, let's just not do it. Let's just keep it as it is. Okay. So to review, with the last commit, we oops, wrong one. C1. So we allowed showing more than one character, more than one Japanese character as the conversion code. And to do that, we basically like abstracted away the slice idea, and we allowed a conversion to write more than one slice. Yeah, that's. I'm saying it very briefly, but that's the idea. So we go through all the possible characters, and if we have more than one character to write, then we split it into shifted and unshifted sections, and we write one of the characters in the shifted area and one of the characters in the unshifted area. So we kind of write it from top to bottom. And if it's more than 6 characters, that's a bug. So we did that. And also what we did during this video is we added the die macro, which will die if there's any problem. So I think that we're just about done here. So I'm gonna stop the video. Thank you for watching.